In this problem, we'll be looking at designing different types of counter circuits. If you have not already done so, you should watch some of the previous videos about counters, and it'll explain a little bit more about how they work. We are going to assume that our counters work as they should, and we're just going to use as our symbol for a counter these symbols over here on the right. So the smaller one is 4 bits, and it counts from 0 to 15, and the larger one is 8 bits, and it counts from 0 to 255. And just to review, the way they work is if we can count on that each clock cycle the counter will increment by 1 binary value, and by that what I mean is it'll start with 0 0 0 0. If depending on what you load, you're going to load some values. So if you load 0 0 0, then it'll start with that, and then at the next clock cycle it will go to 0 0 0 1. So the Q0 output would be 1, and then at the next clock cycle you get 0 0 1 0. So notice when Q0 is 1, Q0 and everything less than Q0, which is nothing, then the next value increments and Q0 becomes 0. Now that'll be important in a minute. And then the next one is 0 0 1 1. So now Q1 and Q0 are both 1. So Q1 and everything to the right of it is 1. So when that happens, on the next step, Q2 will become 1, and all of those 1s will become 0s. And that's how the counting works. Okay, and then on the next step we'll get 0 1 0 1, and then 0 1 1 1 0, and then 0 1 1 1. Now notice that Q2 and everything to the right of it is 1. So Q2 and everything to the right of it is 1. That means on the next step Q3 is going to become 1. And Q2 through Q0 will become 0. And then next step 1 0 0 1. And then 1 0 1 0. And then 1 0 1 1. Now notice Q1 and everything to the right of it is 1. So Q1 and Q0 are both 1. So that means on the next step Q2 is going to become 1, and Q1 and Q0 will become 0. This is important because this is how we can string together counters to make bigger counters. So then the next one is 1 1 0 1, and then 1 1 1 0, and then 1 1 1 1. Okay, now let's see. So this is decimal value 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Of course you should know these binary numbers, but it can help to have them all here, and that was just a quick review of what the counter is doing. So those are going to be your outputs on your Q0, Q1, Q2 with each new clock cycle. So I'm gonna just put, let me just save that little chart right here so we have it. Alright, so now let's take a look at how we're going to build a counter that goes from 0 to 14 and then back to 0. So we want to start with, when we load, we want to load 0. So 0 is 0 0 0, so we want 0 0 0 0. So that's what we want to load. We do want a 1 on the enable because we do want our counter to work. I'm using the smaller one because we're staying less than 15. This is the clock. I may not put the clock in on all of them. And we want it to detect when we get to 14. So let's look at what the binary number for 14 is. So I always think of my binary numbers. If you don't have it off the top of your head, remember your place values. This is 1, 2, 4, and 8. Those are our place values. And 14 is 8 plus 4 plus 2. So 14 is 1, 1, 1, 0. And so we will get to 14. So as we count up, we'll get to 14 when our values, this is Q3, Q2, Q1, and Q0. We will get to 14 when Q3, Q2, and Q1 are all 1. They all have to be 1. And not only that, this will be the first time that they're all 1. So they're not all going to be 1 at any time before 14. They would be all 1 at 15, but we're never going to get to 15. So the first time they're all 1 is at 14. And so what we want to do is detect when they're all 1. So we're going to make the AND of these. So when those are all 1, then that means we've gotten to 14, and that means we want to load again. Because when we load, we're going to load 0. So this will count 0, 1, 2, 3, 4, 5, 6, up to 14. And then when it gets to 14, that will be when Q1, Q2, Q3 are all 1. And the AND of those will be 1. And so then it'll load. And if Q3, Q2, Q1 are not all 1, the AND is 0. And so it won't load. Okay. So let's go on to the next one. And I apologize, I've got a trimmer in my hand, and so my drawings aren't always that great. Okay, so 3, 4, 12. So we're going 3, 4, up to 12, and then we want to load 3. So the first thing that we need to do is to figure out how to load 3. So hopefully you know the binary number for 3. So remember our place value, 1, 2, 4, 8. So 3 would be 1 plus 2, and 0s and 8 and 4. So D0 is 1, so we'll load that. D1 is 1, and then 0 is 0. We want to enable, and we'll have the clock. Okay, and then, so it'll load 3. So it'll start at 3, because that's what we're loading. We'll load 3. And then we assume our counter works as intended, and it'll count up 3, 4, 5, 6, 7, 8, 9. And then when it gets to 12, we want it to go back to 3. So let's think about what the number 12 looks like. So 12 is 8 plus 4. So that's when Q3 and Q2 are both 1. And not only that, it's the first time they're both 1. So we're never going to get these both being 1 before we get to 12. So when these are both 1, then we're ready to load again and to load that 3. So we just need to AND of these. Let's go on. And when those are both 1, then it'll detect 12 and it will go on. Alright, so that's that one. I think I'll, let's see, looks like OneNote has changed the colors available to me. I'm going to do rainbow until it gets too crazy. Alright, yeah, that's me, crazy, rainbow pen. Alright, so this next one is going to go 5, 6, and then up to 15, and then wrap around to 0, 1, and then when we get to 1, we're going to load 5. Okay, so this one's a little different. So let's take a look at what we've got. 5, 6, up to 15, and then go back to 0. Now that's the normal counting sequence. So with this 4-bit counter, after 1, 1, 1, 1, the next step is 0, 0, 0, 0. So that is normal. So we don't have to do anything to make that happen. It's going to go 0 and then 1. But then when it gets to 1, you're supposed to load 5. Okay, so we're going to load 5. So the first thing to do is to figure out what 5 looks like. Again, hopefully you know this. So that's 1, 2, 4, 8. That's D0, D1, D2, D3. 5 would be 4 and 1. So we'll load a 1 on D2 and D0. And a 0 on D3 and D1. A 1 on the enable and our clock. 1, 0, 1, 0. Okay, so now we want to detect 1. We want to detect 1. So let's look at what 1 looks like. So 1 looks like Q0, Q1, Q2, Q3, 0, 0, 0, 1. Well, in the past ones, what we did is we just ANDed together the ones that were 1. And that would be great if we could do that and just have just this Q0 going there. But notice, this is not the first time that Q0 is going to be 1. I mean, as a matter of fact, when we start, Q0 is 1. So as we count through, Q0 is going to be 1 a lot of times. So we can't just look for when Q0 is 1, because that's not going to tell us that we are at the number 1. We have to have Q3 0, Q2 0, and Q1 0, and Q0 being 1. I'm not sure. Let's see, if we start at 5, there might be a way to simplify that, but I'm not going to worry about it because I know this will work. So what I want in this instance, I have to not just check that Q0 is 1, I need to check that Q1, Q2, and Q3 are all 0. So my AND, I'll have nots on these. And then just Q0 there. And that will detect 1, and so when it detects a 1, then it will load, so it detects the 1. So this is not going to be true. It's not going to be true that these 3 are 0 and that's 1 until you get to 1. And then when that is true, then that'll enable the load, and then you'll load the value 5. Okay, so the next one is the rainbow pen is too crazy for me. I'm just not that wild. I'll do purple. That's still pretty crazy. Okay, so this one is, I think, the down counter. Let's see. Yes, the down counter. Okay. So this one is 15, 14, 13, down to 0, and then back to 15. Okay, so it turns out this one is really pretty easy. Let's take a look at our decimal values of our numbers again. And look at the complements of our numbers here. So the complement of 0 would be 1, 1, 1, 1. The complement of 1 would be 1, 1, 1, 0. The complement of 2 would be 1, 1, 0, 1. Now let's look at these numbers we just made here. 1, 1, 1, 1 is 15. 1, 1, 1, 0 is 14. 1, 1, 0, 1 is 13. So if you complement the numbers, then you would be going backwards. So we're going to use our counter to produce the numbers that we have in this chart, which is what the counter does, but then we knot them, we complement them, and that'll get us counting backwards. So this one will look like this. So all we have to do here is we load 0, or 1 on the enable, and load 0. And here's the clock. And we actually don't need to attach anything to the load here because it's just going to count the way it needs to count. This is the full sequence. We don't need it to detect anything and then stop. It's doing all of our numbers from 15 to 0 and then starting back over. All we have to do is complement them. And that's it. And that's this one. Okay, so the next one goes from 0 to 128 and then back to 0. So you detect 128 and then you go back to 0. So we need more than 4 bits to get to 128. So let's look at an 8-bit number. And our place values are those. And so 128, and this would be, if we're looking at our 8-bit counter here, that's Q7, Q6, Q5, Q4, Q3, Q2, Q1, Q0. So 128 looks like that. So 128 is when Q7 is 1. And you're not going to get Q7 being 1 at any time before you get to 128. So all you need to do is detect when Q7 is 1. So Q7 goes to the load. So when Q7 is 1, you're going to load, and what you're going to load is 0. And this will be enable, and that's the clock. And that's it if you have an 8-bit counter. So that's easy enough. Okay, but what if you only have 4-bit counters to work with? Well, here's how how you string 2 4-bit counters together. If you remember when I was going over these decimal values, I made a point of showing that when everything you had to the right of something was 1s, then on the next step you would increment the next bit and turn all of those 1s into 0s. So that's how you can string 2 4-bit counters together to make an 8-bit counter, is when all of the first 4 bits are 1, then that means it's time to increment the 5th bit. So you can think of our second counter as these values are really going to be Q4, Q5, Q6, Q7. And we know to start incrementing these bits when all of the first bits are 1. So what you're going to do is you take the AND of these and you connect that to the enable. That's not a NOT. That looks like a NOT, but it's not. You connect those to the enable of the second counter. And so when you reach the 1111, then you will enable the second counter, and that will make the second counter have that will make the second counter start counting, and it'll turn all these back to 0, and then it'll make D0 1. It'll increment on that one, and it'll start incrementing on those. So that's how you string 2 counters together. And so if we wanted to get 128, and I think I did this on the wrong page. Yes. So, but I'll use it again in a minute. So we'll have the AND of all these goes to the enable on that. So that's how you turn two 4-bit counters into an 8-bit counter. And we want to start at 0, so we'll load 0 on all of these. And we have the clock. And we want the first one to be enabled, so that one will be enabled. And the second one will wait to be enabled until we've counted up to 15, and then it'll go to 16 on this. And then we're looking for when we have Q7 equal to 1, and Q7, remember this is Q4, Q5, Q6, Q7. So when we get that, that's when we want to load. So when this is 1, we'll load, and we'll load both this one and that one. Okay, so on the next one, I already set up my 8-bit counter over here. So on the next one, we're going 16, 17, 64, up to 64. And then loading 16. Okay, so let's figure out what 16 and 64 look like. So 1, 2, 4, 8, 16, 32, 64, 128, D or Q, 7, D6, D5, D4, D3, D2, D1, D0. So 16 has a 1 for D4, and 64, which is the one we're looking for, will have a 1 at D6. Now, so we're detecting that 1, we're detecting the 64. Now, also notice that the one where we had, when we were looking for the 1, we had to be careful because we didn't have Q0 equaling 1 the first time when we got to 1. So you always have to be paying attention to that. And here, but it is true here though, if we start counting at 16, this was a 0. If we start counting at 16, the first time the D6 or Q6 is going to be 1 is when we get to 64. So we don't have to worry about checking to see if everything else is 0 because that will be the first time that happens. So if we had the 8-bit counter, we would enable 1, and we're loading, we would load a 1 into D4 and zeros everywhere else. And here's the clock. And we'd be looking for when Q6 was 1 because that's 64, and that detects 64, and then that would say to load again. So we'll have that. Okay, and then how do we do that with the two 4-bit counters? Well, same way, we've already strung them together to make our 8-bit counter. So we want to load a 1 on D4. So this is 0, 1, 2, 3. This continues here, 4, 5, 6, 7. So we'll load a 1 here. Hold on just a second. Computer's acting up. Sorry about that. Hope I'm back working again. Okay, so where were we? We were loading, and we wanted to load 16, and we needed to put that on D4, which we said was our first bit on our second counter. So 1, 0, 0, 0, 0, 0, 0, 0, and a 1 on the enable on the first one, and the enable on the second one is the AND of all the outputs of the first one. And we're looking for 64, and that's Q6, which is the same as Q2 on the second one. And so the first time that that is 1 is when we want to load. And we'll have our clock. And that will be that one. Okay, so now we have 128, 129, 255, 0, 1, 7, 128. Okay, so we are loading 128, but then we detect, sorry, not a dot, dot, dot there. When we get to 7, that's when we want to reload. So this is one of the ones that we're going to want to be careful about, because 7, let's look at what 7 looks like and what 128 looks like. 1, 2, 4, 8, 16, 32, 64, 128. 7 is 1, 1, 1 with zeros everywhere else. And 128 is 1 with zeros everywhere else. Now, if we start counting at 128, so we'll have 128, and then the next one will be 129, and then 130 and 131 and so forth. There will be several times between 128 and when we wrap back around to 7 where these three are all 1. There'll be several times when that happens. And so we can't just detect when we have 7. So it would be where these three are 7 and everything else is 0. So that would be, we can do that. And so the way that would look would be sorry, problems again. Okay, so the way that would look would be that we have 0, 1, and 2. Those are all 1s, and then everything else is a 0. And that would be what we would load. Or that would be when we would load. And 128 looks like this. And we would enable, and this would be the clock. So, and then for our connecting the 4 bits together, our 4-bit counters together, we would have that. And then our load we would have these 3 as 1s and everything else is 0s, and I can't draw that, so just pretend that all of these are going in there as knots, I am like the messiest person in the world. So pretend that all those are going in there as knots, and then you would load that. And then the load values would be for 128. Okay, enable 1 up here. Now, that's awfully messy. So you could do some thinking about it, or you could do a Carnot map, or you could figure out, well, is there a better way that we could do this? And when would be the first time after 128 that we get all of these ones, and it means 7. Okay, so what's going to happen is when you count, you're going to start with 128. So this 128 bit is going to be filled in. And then you're going to be counting through all these other bits. So you'll start with putting a 1 here, and then you'll have 1 0, and then 1 1, and then 1 0 0, and so forth. And so you'll count like that. And there'll be a lot of times that all of these will be 1. But once you get to 255, then you start over again. And when you start over again, that 128 is 0. So 255, they're all 1s. And then you go back to 0. And then they're all 0s. So when you start at 128, the first time that you're going to get if you start at 128, when the first time you get to 7, you're going to have a 0 in the 128 place and 1s in the first 3 places. That is how you can tell you've gotten to 7 without having to put 0s everywhere else. So what you could do and I think I might, that's nice. Let's see. So what you could do, let's see if this works and if my computer can hold out for just a little bit more. So I've got my first counter and my second counter, and Q0, Q1, Q2, Q3. And these are ANDed together to go into the enable of the second one. And we've got D0, D1, D2, D3, and a clock, D0, D1, D2, D3, and a clock that I don't have room for, Q0, Q1, Q2, Q3. We load 128. And we want it to start over when we get to 7. And we determined that if we start with 128, when we get to 7, that will be the first time that these are 1 and this is 0. Because all the times before this was 1. All the times before this was 1 until we got to 255. And then we started counting over again at 0. And so when we get to 7, the first time, this will be the first time that this is 0 and these 3 are 1. So rather than having to have an AND of everything being 0, we can have an AND of just these 3 and that being 0, and that can be our load condition, which I don't have room for in my drawing. Alright, so that was a lot.